Hello! If you've just started using drones for mapping buildings or structures, or if you have been using drones for a while, you will know that actually using the right flight plan can have a big impact when it comes to creating a high quality 3D model of the structure or building of interest. But with so many different types of flight plans available, everything from a single grid to a double grid to orbits to facade mapping to roof mapping to combined mapping, how do you actually decide which flight plan yields the best results? So in this particular video, what we're going to do is we've actually taken a sample building and we've run many different flight plans on it and produced the results for you to have a look at and decide for your own in terms of what flight plans yield the best results. Let's have a look. Hey everyone, I'm Varun from Hammer Missions, and in this particular video, we're going to go through a couple of different flight plans on mapping out this particular building, and we're going to see what happens when you combine different flight plans and which flight plans actually have the best results. Let's have a look. Right, okay, so we're going to be using hammer missions for this particular task. And so what I've got over here is I've got the same building. So if I sort of zoom in here, here's a 3D model of a building. And this particular 3D model, this particular building has been mapped probably around 6 times. So each one of these tabs that I'm opening up at the moment, each one of those has actually the building mapped with 6 different flight plans. And so what we're going to do is we're going to actually show you the result that different flight plans produce and how having the right flight plan can have a big impact when it comes to creating high quality 3D models. Right, so let's get started. So the very first flight plan that was used to actually capture the data is actually a 2D flight plan. So basically flying a single grid or a 2D flight plan where you are, let me just bring up the image map, where what you're doing is you're essentially flying left to right or right to left and a lawnmower pattern on the top of the building to essentially capture it. And this could be a building or it could be any other type of structure. But basically what you're doing is flying left to right and it's a lawnmower pattern that's being used. So all of these yellow dots is basically a place where the drone flew and took a photo. If I go to the 2D view, it might be easier for you to see. So basically you have this lawnmower pattern, very simple, very straightforward. You might have seen this in different mapping apps. You also be at Hammer Missions, we have this mission and we call it a roof mapping. And so you can have this particular flight plan and this is what was the generated results from the flight plan. So as you can see, you've got the building modeled and you can see the roof pretty clearly. You've got different structures on the roof. They've also been mapped and that looks pretty okay. However, if I sort of move this model a little bit and you sort of look at the facades, this is where the facades rear their ugly head. So essentially, the facades, as you can imagine, have not been 3D modeled at all, and they look pretty terrible, to be honest. And that's completely expected because ultimately we haven't really given the software much of the facade to work with. We do realize that there is this particular facade that has come out slightly better than the other sides, but that's predominantly because it got accidentally captured as the drone was flying in that 2D flight plan. So that's the sort of first flight plan. It kind of tells you that you don't really have that good data on the facades when you're only capturing the roof. So that's the downside of using a single grid flight plan when you are using it for mapping a building. Now let's move to a double grid flight plan. So this is a flight plan where let's bring up the image map once again. So we have a 2D grid that's being flown. So all of these yellow points that you see on the screen, each one of those points is where the drone automatically flew and took an image. And so we're basically flying left to right and then top to down, and we're essentially doing 2 lawnmower patterns that are orthogonal to each other. And so what that allows us to do is that we're able to actually get images for the roof and the facades in the same flight plan. And because the flight plan involved a slight gimbal angle, as you can sort of see from the images over here, all the images that were taken had a small gimbal angle associated with them. And so with the gimbal angle, you're able to actually capture some of the facade. And so with a double grid flight plan, we can tell that, okay, well, the facades have improved in quality. I wouldn't say these are the best results possible, but there is still some improvement in quality when you sort of compare it to a single grid flight plan. So you've got slightly better facades, especially if you focus on this particular facades. If we go back to our single grid flight plan, we are going to be looking at it again. So um, if we compare this particular facade with that particular facades, you can sort of tell that it has had slightly better results on this particular facades, even though the difference is marginal with respect to the overall flight plan and the overall results. So that's the double grid flight plan, and so that's the results you can expect with a double grid flight plan. Once again, the roof gets modeled correctly, but the facade isn't so great. Right, now let's move to facade mapping. So if I bring up the captured images, you're going to look at, oh, sorry, this is not facade mapping. So this is going to be a double grid flight plan again, but with a slight twist. So in this particular flight plan, essentially the drone is always looking at the building. So in a conventional double grid flight plan, if the drone was flying in this direction, flying from top to bottom, it would just be flying straight down. And you would imagine that when the drone is flying this area and it's looking downwards that way, it's capturing more of this building than this building of interest. So in this particular flight plan, what we've done is that we've got the drone always facing the buildings. If you look at all of these photos, the drone is always facing the building, even though it's flying in a double grid flight plan. And that's just the drone sort of flying in reverse sometimes. It's sort of got the camera pointing in different directions. And so to illustrate that in 2D once again with the different images, you'll see that this is a double grid flight plan where the drone is always facing the building and it's always got that sort of directional sort of factor looking at the building. And that actually does improve the quality quite significantly. If you look at the facade, this particular facade, if you can compare all of these flight plans that we've been flying, notably all at this single altitude, the facade actually comes out quite good in this particular flight plan when you compare it to the normal double grid flight plan, or if you compare it to the single grid flight plan. So single grid over here, pretty bad facade. Single grid, double grid gets slightly better, and then we've got the double grid with the camera always looking at the building, and that's actually produced pretty good results. So that's really interesting. And why is that? Well, I think that's because as the drone flies this particular flight, what it's doing is that it's actually always looking at the building. So for the same number of images, or perhaps even lower amount of images, you've only got 106 images over here. Well, and you've got 139 over here, and you've got 78 over here. So for roughly the same amount of images, you've got 50% more data that's actually focused on looking at the building. And naturally, that leads to better results when it comes to the facades. And also, I think there is an improvement on the roof as well. It can be a bit hard to tell, but if you really zoom in, you can kind of tell that the roof boundaries are a bit more blobby over here. They're not as crisp, and they're not as sharp as they are on this particular flight plan. So that's another point of interest to sort of keep in mind, where if you have a double grid flight plan, but the camera is pointing the right way, that can again lead to much better results. Okay, so far we've looked at 3 flight plans. We've had the single grid, we've had the double grid, and we've had the double grid with the camera pointing in the right direction. What happens when we start flying the facade itself? So essentially now we're flying to capture the facade along with the roof in a single grid or a double grid flight plan. So let's have a look at just the facade by itself. So a facade mapping flight plan. So this is a result where the drone was flown around the building, and you can tell from the image map, and each one of those yellow dots, as we know, is a camera point. It's basically where the drone flew and took an image. And so all of those points are basically points where the drone flew, took an image, and this is a multi-altitude mission. So this is an altitude going from a top altitude to a bottom altitude. And lo and behold, that actually leads to much better results when it comes to facades. Well, what a surprise, right? I mean, if you capture the facades well, they get modeled well. That's no surprise. And because it's a relatively small building, what you'll realize is that when you're capturing the facades, if you look at all these images here, you're also actually capturing parts of the roof. And so the roof also gets modeled correctly along with the facades. However, because this is just the facades, you will find that the detail on the roof is typically not as high as what it would be on the facades. But if you look at this particular flight plan, if you look at this particular results by itself, it's about 504 images, so a lot more images, but the results on the facades are much better. So if you go back to our single grid flight plan, sorry, this is the double grid flight plan, looking straight into the building, the facade has considerably improved. If you look at these windows, let's go into these windows a little bit. These are all sort of wobbly and a bit washed out, and everything looks a bit gooey. Whereas if we go to our facade mapping, everything is now more rigid. Everything looks like a window, and you're able to pick up on all these other details which typically won't be available. So, for example, there is some structure here on the exterior wall of the facade. It's visible here on this particular flight plan and this particular result, whereas it's not even visible on this particular structure. So, very, very important to keep in mind that actually the flight plan, the facades, actually adds a lot of detail to your 3D model. And if detail is what you're after, if you're looking for cracks, if you're looking for stains, if you're looking for any kind of defect, being able to get that detail in is really, really important. Otherwise, you will have to go through every single image, and even doing that, you may not find what you're looking for. So you've got all of these different kind of considerations to keep in mind. Now, these were the first 4 flight plans. What happens if we now start combining those flight plans? So let's say if we take the double grid flight plan from the single altitude flight plans, and we take the double grid looking into the building, and we combine it with the facade mapping. Ooh, drum roll, let's see what happens. So first project is basically we've got our double mapping flight plan, and we've got facades added to it. So let's have a look at this. If we bring up our image map once again, so we've got all of these. We've got now 2 different flight plans in the same 3D model. So you've got the 2D double grid, as you can tell. So you've got the double grid looking straight into the building, and you've also got the facades. So the facades kind of capture the facades, and the double grid captures the double grid. That's pretty much it. And if we look at the results, well, the results look very promising. They look much, much better compared to any of the flight plans we've had so far. We can actually see all the different structures. If we just take the facade and compare the facade one more time with our previous facade, you will actually notice that it still has all the details as you would expect. You have all the structures that look very rigid, and they're not gooey anymore. And this is the previous flight plan where we were just flying the facades, and the facades look pretty equivalent, I would say, with slight sort of improvement when it comes to both the double grid flight plan and the facade mapped together. However, the bigger improvement is actually with the overall model. So if we look at this overall model, and if we try to sort of go to different segments of it, we will find that the facade on the other side, or the crispiness of the shape of the entire structure, is actually slightly better when it comes to the 2D grid map alongside the facades. And that's because it's essentially got data from both the roof and the facade point of view, and it's able to actually take all of that data and put it together into one unified 3D model. And so this kind of gives you the ability to be able to look at both the roof and the facade in one view, in one particular model. And so especially if you look at this particular facade over here, the windows are more rigid, and the structure looks good. If we look at the same facade on the facade only flight plan, that also actually looks fairly good. So I wouldn't say that there is a considerable difference between these two. They look fairly good. In fact, I would say that the facade on this side with just the facade mapping model looks slightly better, and it sort of kind of gives you that sense for how everything might be. Although if you look at this particular window, this one has less of the deformation when you compare it with the facade only model. So I would say overall the 2D grid plus the facade still has much better overall results when you really start looking at the minute details and see how they might have come out in the 3D model. So especially if you look at, for example, many different facades and try and compare them. So over here, if we compare this facades, the top row of windows looks much more cleaner when we compare it to this row of facades, which does have every now and then a little bit more of the sort of reconstruction defects. And particularly if we compare it with some of the structures on the ground, because we've got data from two different sources, structures on the ground, such as some of these cars, they also suffer. They also are better when it comes to when it comes to having both the 2D double grid and the facade in the same projects. Now, for the final entry, we've got the double grid flight plan looking inwards. So let's bring up our image map once again. We've got the double grid flight plan where each one of the photos is looking into the building, and we've got facade mapping both in one project. So we've taken all of those images and we've combined them and put them together. So let's have a look at what that looks like. So the facades have come out pretty well as expected. We've also got all of these windows in the top row have come out much better. We've also got this facade looking pretty good, and we've got the final facade also looking pretty good. So this one's also a pretty decent result, and I would say that this particular result is quite neck and neck when it comes to comparing it with the double grid, simple double grid flight plan and the facade. And that's expected because the difference between them is very, very small. So if you look at any of these facades, so let's have a look at this facade again. And in this facade, the top row is looking pretty decent, pretty good. If you look at the railing over here, or if you look at all of these windows tends to be the hardest things to reconstruct just because of reflections. If you look at that and we compare it to our previous flight plan, which was a double grid and had double grid plus the facades, the difference is very marginal, I would say. It's a bit hard to sort of see, but I would say that actually the railings over here, or these particular structures, they got reconstructed slightly better when you compare it to the double grid only flight plan. But then again, the double grid flight plan over here has much better window reconstruction. The 3D model looks much better on the windows when it comes to that particular part of the flight plan. But if you compare it to the facade only flight plan, both the windows and the railing over here have had some reconstruction issues, and also the railing over here. So we kind of see that actually conclusively, we can say by combining the double grid and the flight plan leads to much better results. And so when it comes to that sort of the next 5% improvement, and then the next 2% improvement, and the next 1% improvement, it's actually quite valuable to have multiple flight plans flown together and looked at from a modeling perspective. And we can actually do this analysis by taking different structures, different parts of the roof, and we will find that actually we get slightly different results, slightly different levels of understanding in terms of how everything has been reconstructed. And so that's just purely because every one of these flight plans has different input data points, and therefore the results are very much dependent on what was captured. So all in all, I think there are a few key conclusions we can draw from here. If you look at just the facade or if just the roof mapping, or just a single grid or double grid, if there is no facade captured, well, you're not going to have great facade results. I think that's sort of obvious, but I think that it's something that needs to be said because not everyone in the industry knows this. And it's quite important to understand that actually, if you want to 3D model a building completely and perfectly, really important that you get all the facade images right. And getting the facade images right is both a science and an art because you've got to make sure that you capture all the images in the right place, and you need to make sure that you have an efficient flight and you're capturing the right amounts of data as well. So as you can see, progressively the facade gets better with all of these flight plans that I'm showcasing at the moment. And one of the big conclusions we can draw definitely from this video is that capturing the facade improves the overall 3D model for the facades as well as the roof. And once you have both the roof and facade combined in one project, that yields the best results. And within that, whether you have the right flight plan for the roof and the facade, there's the further optimization that you can make. And so I think that it's really important to think about what is it that you're trying to capture and then making the decision accordingly. So this particular video assumes that the entire building was our target, but we have to kind of also appreciate that not all projects are the same. And ultimately, the reason why we are flying drones to capture this data is not so much because we want to make a nice, pretty looking 3D model, even though that's great and that's really helpful. But the data ultimately is forming some form of insight, some form of input into a decision that needs to be made. Hey, does this roof needs replacement? Does it have a lot of water ponding issues? Is the slope correct? Are we looking at changing all of the sealants on the windows? And there is some decision that an end decision maker is trying to get to, and understanding that decision and what inputs will be required for that decision is really important. And that's how you back calculate what the 3D model should look like, and you back calculate what is the right flight plan, given the fact that you have this end decision to actually help make. So thanks so much for watching. We hope this video was interesting. I've actually made a whole video on flight plans and how to use different flight plans for different types of use cases. So if you're interested in learning more about flight plans and how they follow through to 3D models and then how that follows throughs to AI and decisions, go watch that video next. Thanks so much for watching. We'll see you in the next video.